Hey, today we're going to solve systems of quadratic equations. So both of the equations are going to be quadratic, but it's the same process of solving by systems. So we want to get a variable by itself. In this case, we already have this y by itself. So this is going to go in place of this y up here. So we'll have 2x squared minus, and then in parentheses, we put -1/2 x squared plus 6 equals 4. So we just put the second equation into the first equation. Now you'll notice there is a subtraction out front here. So the next thing we need to do is distribute. If you'd like, you can think of that as a -1. So we're going to have 2x squared, and then that'll be plus 1/2 x squared. And then -1 times 6, that's -6 equals 4. Now, we do have a quadratic, but let's go ahead and combine like terms. So 2 plus 1/2 is 2.5. 2.5 is the same thing as 5 halves x squared. And then since it's a quadratic, I'm going to go ahead and get it equal to 0. So I'm going to subtract the 4. And I get -10 equals 0. Now, this fraction is a bit annoying out front, so what we can do to fix that is we can multiply everything by 2. So we can just multiply by the denominator. So 2 times 5 halves is just 5x squared. But we also have to do 2 times -10, so that's -20. But 2 times 0 is still 0. So now what we can do is we can divide everything by 5. We can just get rid of that 5 completely. And we get x squared minus 4 equals 0. Now you could either solve this using square roots, or you could solve it by factoring. This does factor into x plus 2, x minus 2. So the answers would be -2 or 2. So those are your x values. So what we have to do is plug them back in to figure out what the y values are. So we're going to take these x values and plug them in up here. So I'm going to do y equals -1/2. First, I'm going to plug in the -2. So that's -1/2. -2 times -2, that's what squared means. That's 4. So that's -2 plus 6, which is 4. So one answer is -2, 4. Because when I plug in a -2, I got an answer of 4. Now I'm going to go ahead and plug in the other answer of 2. So I'm sorry, I'm all over the board here, but I'm going to plug in a 2 right there. So -1/2, 2 squared plus 6. You'll see 2 squared is also 4, so we still get 4 as our y value. So the other solution is 2, 4. Because when I plugged in a 2, I got a 4. So these are my 2 solutions. And again, because they are quadratics, it is possible for quadratics to cross at 2 different locations. So if you think about what these graphs can look like, they are crossing at 2 points, and that's why we have 2 different solutions. Okay, let's try one more example of this. So it's the same idea. I already have the x by itself here. So I'm going to take this and plug it in for that x that I see right there. So I'm going to have y squared equals -18 times. Then I'm going to have the 1/18 y squared go in place of that, plus 72. So I get y squared equals, well, -18 times 1/18 is just -1 y squared plus 72. So I can add the y squared to the other side. I want to try to get those y squareds together. So that's 3y squared. And at this point, you can consider sorry, I just realized I made a really silly mistake. I was looking at the wrong number. When you add 1 to the side, that's just 2. So you have 2y squared. So sorry about that. Now what you're going to do is divide everything by 2. Again, I'm just going to use square roots to solve this since I just have a y squared. I really don't have to factor. So then I take a square root of both sides, and we have to remember when we take a square root, we do get plus or minus, and then the square root of 36 is just 6. So now what I need to do is, I know that that's what y is, so I'm going to plug that into the y right there. And again, I have to plug in both the 6 and the negative 6. It is possible that I would get 2 different y values depending on which one I plug in. So first, I'm going to do the positive 6. Don't forget that it's squared in the equation. So 6 squared is 36. So that's going to be 2. So x is 2 and y is 6. Now I'm going to go ahead and plug in the negative 6 for the y. Again, remember that's the y, so it's going in for the y. But again, because when you square a negative, that's also positive 36, I'm still going to get a positive 2. So the answers are 2, 6, and 2, negative 6. But again, please don't think that when you plug the numbers in, you always get the same answer. Okay, so that's how you can solve a system of quadratic equations. Now, the next example is using a system to just solve a quadratic equation. So there's more than one way we could do this. We could get everything to one side in order to solve this. I'm just showing you a different technique. So another way I can solve this, and you can solve any equation doing this, I'm going to graph this in my y1, and I'm going to graph this in my y2, and literally I want to see where are they equal. So you can see here's my y1, which is just this side of the equation. Here is my y2. Okay, so here you can see I've typed in each of those equations, or each side of the equation, into a different y1 and y2. So the left side's in my y1, the right side's in my y2, and I'm going to go ahead and hit graph. And I want to make sure that I see both the parabolas, and I can kind of see what's going on, but I really need to see up higher, up here towards the top. So I'm going to adjust my window, and I don't need to see farther left and right, but I do need to see higher up. I really don't need to see all the way down there. So I'm going to change my y maximum to like 20 instead, just so I can see a little bit clearer what's happening. And it looks to me like there's 2 places of intersection. There's a point here, and there's a point here. So what I'm going to do is I'm going to go ahead and use the calculator to figure out exactly where those hit. You can see on your paper they graphed these for you, and they're kind of estimating where these points of intersection are, but I'm going to use the calculator to figure it out exactly. So make sure you're doing this along with me. Once you get them typed in there, you're going to go to second, calculate, and you are looking for the intersection. It'll ask first curve, so just move so you're close to one of the intersections. You'll hit enter. Second curve, just hit enter again, and it'll just take you on to the other graph. Guess, just hit enter again. Again, we're just focusing on this answer right now. You can only do one at a time. So I just hit enter a bunch of times, and I see the first intersection is -1/2, 10. So one intersection is -1/2, 10. And then I repeat the process for the other one. So I go second calculate, number 5, go close to that intersection point and hit enter for first curve, just hit enter again for second, enter again for guess. It's really simple. And the other answer is 1, 7. Right, now realize that these are just the 2 numbers that makes the equation equal on both sides. So the solutions are actually just the x values in this case. So the solutions are -1/2 and 1, because those are the values that make both sides of the equation equal. When I put in a -1/2, basically the equation says 10 equals 10. And when I put in a 1, I get 7 equals 7. So these are the x values that I am trying to solve for. So that would be the answer. Okay. Okay, so we are going to try one more of this type. Again, we could get the x squareds to one side. You can see with the fraction here, it's not going to be necessarily a pretty equation to try to solve. We could get it set equal to 0. We could do the quadratic formula. I'm just showing you an alternative way to solve this. So this is what's going to go into my y1, and this is what's going to go into my y2. So let's go ahead and type that in there. I'm just going to go ahead and pause, go ahead and type those in. Okay, so you can see in the first one, I typed in my negative x squared plus 3x plus 14, so that's the left side of the equation. And on the right side, I put in my negative 1/4 x squared plus 5. Now, I do want to set my window back to normal, so I'm just going to go ahead and do zoom 6 when I graph, and then I'll adjust if needed. I can see there's one parabola, and there's a second, and it's only possible for the parabolas to hit it both at 2 spots. So even though there's more going on up here, I really don't need to see it. This is one point of intersection, and this is the other. So I'm going to allow the calculator to find those points of intersection for me. So I'll calculate the intersection for the first curve. So just move your cursor until it's close. I know it's right around x equals -2, so I just moved until this was close to -2. I'm going to go ahead and hit enter, 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 and it'll find this value for me. So that's -2, 4. And on your paper, we're just going to just draw a quick sketch. So the first one kind of looks like this. The second one looks more like this. So my first point of intersection is -2, 4. And my second point of intersection, then you're just going to move over, and I know it's somewhere over here. Look at your x values. I know it's more around x equals 6-ish. So I'm just going to keep going until I get close. And I'm going to hit enter, 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 and I get 6, -4. So this picture doesn't really make sense. It's more down here. The other one is 6, -4. So again, what that means is when I plug in a -2 to both sides, I get 4. So one answer is -2, and then the other answer, when I plug in a 6 for x, both sides will be equal to -4. So the answer would be the -2, and then also the 6. Those are the x values. This isn't a system of equation in terms of having both an x and a y in the equation. You can see there's no y there. That's why the solutions are just the x values, whereas with the previous examples, we had both an x and a y, so the solutions were the full points. So that's kind of the difference between those.